Okay, so again, this is called the intermediate value theorem. Intermediate means in between. You're trying to prove that there's a value in between two other values. So here's what it is like officially. Ready? I printed it here so you wouldn't have to write it because I know it seems like, gobbledygook. If a function is continuous, maybe like circle, highlight, underline that. You have to be told that or the theorem goes out the window. If you don't have continuity, you can't prove anything. That is like super crucial. Continuous on an interval from A to B, and C is some value in between. In between is like what the word intermediate means. C is in between these other two output values. Then there has to be an X value that gave it to you. In layman's terms, it's if there was an output value, it had to come from somewhere. There has to be an X value that gave it to you. I learn best by pictures. I'm a very visual person, so we're going to just draw a graph so that I can explain what all that means to you, because I realize that that's like a whole bunch of words, but a picture helps a whole lot. So just draw yourself some kind of graph. Just draw like a line or a little doodle. It doesn't matter as long as it is continuous. Very good. As long as it's continuous, it doesn't matter. Just draw something. I just drew a little squiggle, right? So here's a value A. And we're going to find that value on the function. Its output value would be f of A. Did this on the quiz. If I asked you to plug in 1, you would find f of 1. It's like whatever that output value is. So A, f of A. Are we all still on board? Okay. Then you're going to come down here, and this is B. Find where that value hits the graph. And what is that output value going to be called? F of, very good, f of B. Because I realized at a certain point in math class, it feels like the alphabet threw up on your paper because it's like, do you remember when math used to just like be numbers? That's all these variables. But it should make sense. A, f of A, B, f of B. Watch, this is what the theorem is saying. If there is some value here, I'll use a different color, C, that is in between those. If there is some value C, and if you don't like it that it's called C, I'm really sorry. You can actually call it any other letter of the alphabet you want, besides A and B. We used those already. If that value C exists, what we're saying is there's some X value that gave it to you. What the theorem is saying is this must exist. It has to be there. If there is an output, it came from somewhere. So if there is an output, there must have been an input that gave it to you. Does that seem logical? Like that should seem logical. I realize then like we go to do a problem and it's like all this vocabulary and it gets kind of tough to read through. But in essence, that's really it. Okay, so let's read the first one. If f of x is, if you aren't told that, you literally can't do the problem. Okay, if the function is continuous, if f of 3 equals 10 and f of 5 equals -7. Now, some people don't like the function notation. That's okay. Write them off to the side as ordered pairs. What that means is you have the point 3, 10 and the point 5, -7. If you don't need that, then fine, don't write it. It's like, I just know the function notation throws some people off. So if you want to write it as an ordered pair, just write that off to the side. That's what that means. If you have those 2 points, here's the question, yes or no? Ready? Is there a 0, which means a root, like we were doing up here, on that interval from 3 to 5? Does there have to be a 0? Look at your output values, and I just want you to tell me, or you can even think about where these are graphed. Like, oh, 3, 10 would be like over here, 5, -7 would be down here. You can even like think about it visually, that helps. Does there have to be a 0? Yes. Okay, so our common sense tells us yes. Unfortunately, there is a little bit of writing in order to explain that. You have to mention that the function is continuous. Like you have to mention that, okay? So we're gonna say, since f of x is continuous, and you can abbreviate, I don't care. But you just have to mention that. Because if it's not continuous, the whole thing goes out the window. Since f of x is continuous, and remember what the theorem's called? Intermediate. You have to mention the word between. We're trying to prove that there is a 0 on this interval. So we're going to say, since 0 is between f of 5 and f of 3. Do you see how f of 5 is the smaller one? Like that's the negative one. F of 3 is the bigger one. Okay, so f of 5 is smaller than 0 is smaller than f of 10. That's the shortest way to put it. Some people do not like that though, and they would prefer to write it out in words, which you can do as well. It takes a little bit more writing, but it makes more sense to some people. So you can do this. You can say 0 is between f of 5 and f of 3. If you want to write that instead, it means the exact same thing. And again, that makes more sense to lots of people to write it out like in words. Right? So since the function is continuous and 0 is between, there's a 0 on the interval. There is, yay, a 0 on the interval 3 to 5. Yes. Oh, I'm sorry, 3. Yes, you're right. F of 3, which is 10. I apologize. You want to use the 3 and the 5. You want to use like the inputs there. F of 3 and F of 5. Thank you. I'm sorry. Oh my gosh, if this was the AP exam, I would have gotten that wrong. Do you see how easy it is to mess stuff up? Be really careful. So you have to mention continuity and you have to mention between. Okay, in between. And then there's your grand conclusion. On the back, we have a lovely table. Use the table of values for the continuous function f of x. You have to be told that or you can't use the theorem at all. On what intervals? But this is always hilarious to me because I'll be like, on what interval? And someone will be like 3. An interval involves a starting and an ending. Does that make sense? Like you can't say my interval is 2. Like it would have to be from 2 to 3 or something like that. Like an interval is from somewhere to somewhere, right? On what intervals must there be a 0? Let's look at all of them individually. Does there have to be a 0 on this interval 0 to 2? Would there have to be a 0 on that? Yes, why? No, that's not the reason why. Because 2 is positive and -1 is negative. So 0 would have to be in between them. Do you see what I'm saying? All right. Would there have to be a 0 on this interval from 2 to 3? No, because this is negative and this is negative. 0 is not going to necessarily. Now, could it be? Because I don't know what's going on in between. Maybe it could swoop up there and go through, but I can't guarantee it. Right? How about from 3 to 6? No, we still don't have a sign change there. How about from 6 to 8? Yes, okay, because this is negative and this is positive. 0 has to be in between. And then how about from 8 to 11? No, okay. So we are going to say f of x has a 0 on, now which 2 intervals did we say? There were 2 of them, right? 0 to 2 and 6 to 8. I realize they look like ordered pairs, and I'm sorry, but you do want to use the parentheses, not the brackets. I don't have a way around that. I'm sorry. I realize they look like ordered pairs, but they're not. They're intervals. F of x has a 0 on 0 to 2 and 6 to 8 because, and you can abbreviate, what have you got to mention? There's 2 things. What's the first one? Continuous, because f of x is continuous. And the other thing is between, continuity and between. And here's how you can kind of get away with it whenever it's a table of values that's given to you. Instead of using the word between, you can say a change in sign. You can say 0 is in between these if you want, but I think change of sign is more succinct. It'll be less writing. I don't want you to do like a whole paragraph. So because the function is continuous and changes sign on those intervals. So I would just check each of them individually and see where 0 has to be in between. Continuous, continuity, and something in between. Now, typically this theorem is used to prove that there's a 0. The little activity we did before this was proving there's a 0. But you can technically prove it for any number in existence, as long as it's in between. So what we're going to do for this last one is you're going to write exactly the same thing, but instead of 0, it's going to be a different number. It doesn't matter. It can be any number. Don't discriminate. All right. F of x is continuous and f of 2 equals 17. And again, if it helps you to write it as an ordered pair instead, you can do that. That helps some people. And f of 8 equals 9. And if you wanted to even like off to the side kind of graph where those look to see it visually, that helps as well. Does the function equal 10? So it's just 10 instead of 0. You coming with me there? Eyes open would be good. 10 instead of 0, it's the only difference. Do we have to equal 10 at some point from 2 to 8? Well, is 10 in between these two? Yes, yay. So yes, we're gonna write the exact same sentence we did for this one, except instead of 10, it's gonna be 0 and we have a different interval. You're just gonna change the numbers, all right? Since f of x is continuous, and now again, you can write it in words. Some people prefer words to math symbols, and I totally get that. You can say 10 is in between, what was it? F of 8 and f of 2, if you want to write it out in words like that. But I think the shorter way to say it is f of 8 smaller than 10, smaller than f of 2. 10 is in between those, because this one's 9 and this one's 17. 10 is in between 9 and 17, last time I checked. So since that is all true, there is, now I guess I do kind of have to change the sentence a little bit, because over here we just said there is a 0. We can't say there is a 10. That doesn't, like, that's not a vocabulary word like there. So we would say there is a value where f of x equals 10 on the interval 2 to 8. And I'm sorry, I'll move my fingers. Yeah, you can't say there is a 10. That's not a thing. We have a vocabulary word, 0, that means something. Wouldn't that be cool though if you could say that though? There is a 10, or there is a whatever. You'd say there is a value where the function equals 10 on that.